Hey, so one of the big differences between this theory and existing ones is that it predicts the presence of tunneling. Now, tunneling is not necessarily always the right term, it depends on the context, but in the simulator, it looks like tunneling. And we're all familiar with, like, for example, a high power laser cutting through metal. Kind of that same concept, except this same sort of thing could happen with stuff you wouldn't normally expect it to. For example, light and spacetime. I was thinking about how the tunneling behavior exhibited in the simulator was more stable if there was energy moving in both directions than simply one. I know what you're thinking, light doesn't move in a straight line. This is an abstraction. Pretend it's moving in a wave and we're zoomed out. It's a fractal, so you can take any arbitrary slice of the scale dimension and see similar effects. As you can see, the single direction tunnel eventually falls apart. The bidirectional tunnel is much more stable. Things crossing the tunnel do so like it doesn't exist. But things on the perimeter of the tunnel get sucked in. This had me thinking that this type of effect might actually be happening between the Earth and the Sun because the Earth reflects sunlight. If the Earth was a ball of ice, it would reflect a lot of white light. Based on what I'm seeing, this would help a tunnel start to form between Earth and the Sun, allowing for more focused light. As the Earth heats up, I would see the tunnel splitting and focusing in on the areas that are frozen. Light between the tunnels would get pulled in. As the ice caps continue to melt, the tunnels would get smaller and the overall vortex focusing light on Earth would weaken. With complete melting, it's entirely possible the tunnel would collapse and Earth would see substantially less light, triggering a new ice age. If the Earth were to have heavy cover due to an asteroid, a constant barrage of dark storm clouds, or heavy volcanic activity, it would cool. So this reveals a completely different way of thinking about climate science. Instead of the Earth being at the mercy of the Sun, the Earth is literally communicating back to the Sun whether it needs more or less heat. This type of mechanism would help substantiate the fact that we have life and Earth has been stable enough for life to thrive. And by having this sort of corrective mechanism in there, it helps maintain the temperature that's necessary to keep it in place. Of course, the climate is extremely complicated, so it's difficult to say that just one mechanism really does anything. Now, this might have been more of a mechanism perhaps in Earth's early history, but it's entirely possible that it is completely drowned out, assuming it even exists, with other things. That said, I do get a little concerned when I hear about a startup wanting to increase the albedo of Earth's atmosphere. Because based off of what this is showing, it carries the risk that it actually might do the exact opposite of what you think. I could have put more here, but I was running low on space. Feel free to pause the video if you want to read through it, but the gist of it is essentially that the idea that holding in heat is universally bad is not necessarily the case, and the idea that reflection is universally good is also not the case. And then after doing a cursory lookup, it appears that albedo has largely stayed about the same since we started recording it, which wasn't even that long ago. So we don't really have any data to substantiate or deny this. It makes a lot of sense to prove that this tunneling is actually a real thing. It's hard to find examples where this kind of thing might be noticeable and distinguishable from all the other processes that look very similar. One thought that I did have is maybe there's a star out there that's far away and it's tunneling at us right now. And then, boom, it shows up and everyone's like, hey, where'd that star come from? That's happened a few times in history. And most of the time, the explanation is that it was probably a supernova. And if you think about it, it probably was. if something were to be tunneling towards us and it was close enough that we would see it, it most likely would have done its tunneling by now. So that's a bit of a problem. Now, I tried looking for more modern things, not just historical accounts, and couldn't find any. Another thing that occurred to me is that perhaps this tunneling happens every single day and night. So when you look at the stars, as you can see through here, if stars were to form tunnels at night that help focus their light, they would get erased as the atmosphere illuminates every morning. This would also prevent tunnels from forming at dusk. It has been my observation that despite the sky being dark enough to see stars, I often have to wait until later at night for them to come out. This might explain why. It occurred to me that a time-lapse video might capture this effect. We're looking for evidence that a star appears that's brighter than the background and illuminates faster than non-stars. They would presumably fade in much faster than existing stars would become brighter. We actually see quite a few stars sort of pop in, just pop, 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 one after the other, which does seem like, are we confirming the theory? If stars were always the same brightness, wouldn't they appear to fade in like this, not pop in? So the answer to that question is maybe, but it's hard to say for sure because there's just a lot of variables involved. And no one's really brought it up before, so it does seem like we would have noticed. I will say that at times I've taken night vision goggles and pointed them at the sky and have seen stars I couldn't see with my eyes. And that would seem to give evidence that there isn't any obvious tunneling. But it's also worth pointing out that one data point is probably not enough. I did look at other time-lapse videos, and almost all of them have the same effect to them. And so that would feel like conclusive evidence, except the problem is the way they make these videos is that they actually have the camera change its settings automatically. And so those settings include drawing in more light as it gets darker. So these stars popping in are actually an expected behavior. And so it's difficult to differentiate from that expected behavior and something that would probably be very subtle in this case. And unfortunately, the software used does a lot of stacking, does a lot of processing between a bunch of different photos. And as a result, it's a bit almost magical how it gets to that final product. And so it's hard to say whether you're actually seeing a real phenomena or an artifact of the software making it. At the very least, I think everyone can look at the time-lapse photos and say that there's definitely some sort of pop-in happening. It's just a matter of, is it real? And so this concludes part one. I'm going to keep on trying to get more research done and see if I could make some headway into finding some sort of experiment that can substantiate the existence of this tunneling effect that I think might be happening. Please remember to like the video if you did, and subscribe if you want to keep following along and see where this heads. Thank you. Hey, so after I made this video, I realized it was dusk and the perfect time for me to run out and see if I could see pop in for myself. Well, after watching the stars, I actually saw something very interesting that I'd never seen before, which is that as I saw a star, I'd see it appear and disappear. And then it'd appear and disappear, and it was extremely faint. And then at one point I saw something that looked like this. It was like just light, just kind of doing like a wave tail. And it was also very faint and very hard to distinguish across the sky. So my conclusion is that what's happening is that these stars really are brighter than their background, but they're only visible for like maybe like 5% of the time, and then 10% of the time, and then 30% of the time. And so I need to do a little research and see whether or not I can recreate that kind of behavior in the simulator. And then I also need to do some research to see whether that was actually expected, and the existing explanation that these are atmospheric effects would explain that exact thing sufficiently.